Okay, welcome. Today we are going to discuss about Romberg's integration. So it is a modified version of trapezoidal rule used to find a better approximation to the integral of the function f of x from a to b. So it was discovered by a mathematician called Richardson. So I'm going to describe how the method works and then do an example to illustrate how you need to behave when you meet a question involving this method. So we use the trapezoidal rule several times successively, having h, this is mesh spacing, and apply the formula I h comma h over 2 equals to 4I of h over 2 minus IH divided by 3 to each pair to each pair of values as per the following table, for the following scheme. So then this is what you are, the scheme that we have. So we have in a form of a table. So we have I of h, and then next will be, you leave us some space, I of h over 2, and then next one, I h over 4, and then next one, I h over 8, and then in between IH and IH over 2, we have IH, comma, H over 2. In between IH over 2 and IH over 4, we have IH over 2, comma, H over 4. In between IH over 4 and IH over 8, we have IH over 4, comma, H over 8. And then in between IH over 2 and IH over 2, IH over 4, we have IH, comma, H over 2, comma, H over 4. In between these two values, we have IH over 2, comma, H over 4, comma, H over 8. And then between these two values, we have IH, comma, H over 2, H over 4, comma, H over 8. So then let's describe what each of these values in this scheme means. Where So we have IH, comma H over 2 is given by a third into 4I H over 2 minus I H, and then IH over 2 comma H over 4 is given by a third into 4I H over 4 minus IH over 2, and then etc. And then let's start with those with three values. So we have I H comma H over 2 comma H over 4 is given by a third into 4 times I H over 2 comma H over 4 minus I H comma H over 2, and then I H over 2 comma H over 4 comma H over 8 is given by a third into 4 I H over 4 comma H over 8 minus I H over 2 comma H over 4, and then next value I H comma H over 2 comma H over 4 comma H over 8 is given by a third into 4 I H over 2 comma H over 4 comma H over 8 minus I H comma H over 2 comma H over 4. So this is the formula that you need to remember that. So just the basic formula that you need to remember is that I H comma H over 2 is a third into 4 I H over 2 minus I of H. It's like we have a third into 4I2 minus I1. Like we want to get I3 is given by this. So when you substitute I3 for this H comma H over 2, so this is what we have. Now we'll do an example to illustrate this. So an example. Use, so maybe before we give an example, let's now an NB. The computation is continued until successive values are closer to each other. So an example, use Romberg's integration to evaluate the integral from 0 to 1 dx over 1 plus x squared, correct to 4 decimal places, by taking h equals to 0.5, 0.25, and 0.125. So in this example, we are going to see how you need to define those I values. So solution. So remember, this just an iterative method for applying trapezoidal rule more than one time to get a better approximation to the integral. So solution. So solution we have, so evaluate given integral. Actually, even in this scheme, we can actually label these values. So you can label these values as, if this is I1, this is I2, this is I3, this is I4, call this one, this is I5, this is I6, this is I7, this is I8, this is I9, then this is I10. So to get, so in this formula here, where we had this one, this is, you can say this is I5, as we have labeled there. So I5 will be given by this. So the thing is that now to define, with this labeling, to define I5, the same as a third into 4 I2 minus I1. And then similarly, you can define I6 is a third into 4 I3 minus I2. And then in a similar manner, you can define I7 is given by a third into 4 I4 minus I3. Similarly, I8 is given by a third into 4 I6 minus I5, and then I9 will be given by a third into 4i7 minus i6, and then i10 is given by a third into 4i9 minus i8. So remember, this is the original scheme. This is the original scheme. That's what we have. Now let's go back to the given integral by using trapezoidal rule. So with h equals to 0.5, so we have this table x and then f, so 0, 0.5, and then 1. So when you replace, so remember the function here is 1 over 1 plus x squared. 1 and then 0.8, 1 will be 0.5 when we replace into this function here. So therefore so with respect to this table, so we call that one I1. So I1 will be given by integral from 0 to 1 dx over 1 plus x squared equals to, remember the trapezoidal rule is h over 2 into, so this we have f naught plus f2, or this f naught, f1, f2, and then plus 2 f1. Spacing will be 0.5 over 2 into 1 plus 0.5 plus 2 into 0.8. So that will give us 0.775. And then number 2, h equals to 0.25. So we make that table. So we have x value of f 0, 0.25, 0.5, 0.75, and then 1. So the values here is 1, 0.94112, 0.8, 0.64, 0.5. So we can label this as our f naught, f1, f2, f3, f4, and then we say the I2 will be given by the integral from 0 to 1 dx over 1 plus x squared. By trapezoidal rule, we have h over 2 into f naught plus f4, and then plus 2 into f1 plus f2 plus f3. This will be 0.25 over 2 into 1 plus 0.5 plus 2 into 0.9412 plus 0.8 plus 0.64. When you work out this one to nearest four decimal places, you get 0.775. 7828. So this becomes our I2. So I3 will be defined when H is taken to be 0.125. So H equals to 0.125. When you work out, you should get that the value of I is 0.784H. Just do the normal thing. So have a table, X and F, so 0.125, so 0.25, etc. up to 1, and then you get the corresponding values of F, and then apply the trapezoidal rule. So therefore now, we can now make this, the use of this, that this I, so we can actually now write the values. So our I, just go back to this original table. So we have I1, I2, I3. So we need so we can just say, so we have I1, I2, I3. We can just now, that's the original one. So this is the scheme. Of course, we are only reaching 3. So then it means that then we have the scheme will be, so we say here we have the scheme. So we have I1, I2, and then I3. So this I1, I2, let's call this one I4. Remember, this is just notation. And then this one, call it I5. And finally, we call this one I6. So then I4 from this scheme will be given by a third into 4 I2 minus I1. So which will be given by a third into 4. I2 is given by 0.7828 minus I1 is given by 0.775. When you work out this one, you should get your I4 to be given by 0.7854. And then I5 will be given by a third into 4 I3 minus I2, which will be I5 will be given by a third into 4. I3 is given by 0.7848 minus I2 will be given by 0.7828. When you work out this one, you should get your I5 to be 0.7855. And then I6 will be given by 1/3 into 4 I5 minus I4. So therefore, we'll have a third into 4. I5, we have gotten the value to be 0.7855 minus I4, 0.7854. When you work out this one, you get 0.7855. So therefore, now we can write the numbers. So we can say, so our scheme therefore is, so we have h equals to 0 0.5, 0 0.25, 0. So this is the value of h, 125. So the corresponding value for this one is 0 0.775, 0 0.7825, 0 0.7848. And then between these two values, we have 0 0.7854. Between these two values, we have 0 0.7855. Between these two values, we have finally 0 0.7855, which indeed we did. We wanted to get that we get values which are very, very close. So remember, all these are the approximations of the same integral. Now, because these two values are the same, these two values, this and this value, so therefore our integral is approximately given by this value. So therefore, the value of the integral is 0 0.7855, the nearest 4 decimal places. So we do the second example. Example 2, use Romberg's integration to the nearest 4 decimal places to evaluate integral from 0 to 1.2 of 1 over 1 plus x dx. So this is the question. So our solution, here we have the function f of x is given by 1 over 1 plus x. So we can take h to be 0 0.6, 0 0.3, and then 0 0.15. So therefore now, where now here we, this simply means h is 0 0.6. When you divide by 2, you get 0 0.3. So this is what we are trying to mean. And then when you divide by 4, we get 0 0.15. Remember, you can go further and say h over 4 over 8 and get another value. So let's draw the table. X and then f. So 0, 0 0.15. So this table is just summarizing all the values that we need. So 0 0.30, 0 0.45, 0 0.60, 75, 0 0.90, 1.05, 1.2, say 0. That's the last value. So here we have 1. This is 0 0.8692. This is 0 0.6896, 0 0.68. Please try to confirm these values when you put into the function. and then 0.6250, 0.5714, 0.5263, 0.4878, 0.4545. So using now the trapezoidal rule, so there are three cases. H equals to 0.6, we get excuse me. So I1 will be given by I of H is I of 0.6, which will be 0.6 over 2 into 1 plus 0.4545, then plus 2 into 0.6256. Please reconfirm 0.8113. Now when H equals to when you say H over 2, which is 0.6 over 2 is 0.3, we get I2 equals to 0.3 over 2 into 1 plus 0.4545 plus 2 into 0.7692, 0.625, 0.5263. So when you work out, you should get 0.7943. And then H over 4, 0.6 over 4, which is 0.15, we get I3 equals to 0.15 over 2, 1 plus 0.4545 plus 2 into 0.8695 plus 0.7692 plus 0.6896, 0.6250 plus 0.5714 plus 0.5263 plus 0.4878. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what we have. So when you work out this one, you should get 0.7899. Now, therefore, we have I1, I2, I3. So between I1 and I2, we call it I4. Between here, we call it I5. And here we call it I6. And then we use the same formula. That to get I4 will be a third into 4 I2 minus I1. And then we have I2 and I1, so we can also define this. And then I5 is a third into 4i3 minus i2. And then i6 will be a third into 4i5 minus i4. So when you work out, so i4 will be given by 1 over 3 into 4 times 0.7943. So this is our I2, can see it from here. Minus 0.7943. So this will give you 0.7884. And then I5 will be a third into 4 is 86. 4 into 0.7899 minus 0.7943. So this gives you 0.7884. And then I6 is a third into 4 times 0.7884 minus 0.7886. So you get 0.783883. So the table of values is the table of values, or simply the scheme, is, so when H is 0.6, 0.3, and then 0.15, so the values are, so 0.8113, 0.7948, so the first value was 0.79, and then we have so this is 0.813. I remember this one should be this value here, the 0.8113. So confirm this answer. So we have 4 times 0.7943 minus 0.8113 divide 3. Yeah. fine. Yeah, so that was typo there. So there's has to be 0.8113. And then we have 0.7899. So here we have 0.7886. This is 0.7884. Then last year is 0.7883. So this last value is the value that we pick. So this is the value that we pick, and therefore we say, therefore, I equals to the integral from 0 to 1.2 of 1 over 1 plus x dx is given by 0.7883, the nearest 4 decimal places. So get as many examples as possible on Romberg integration and use the same approach to work out the solutions. So remember once now, maybe just before we stop, so the first thing is I just use, when you have 4 values of you will have h, you can always extend your formula. Like for the previous case, we have picked our starting h to be 0.6. So you can then, if we say h over 2 will be 0.3, h over 3 is 0.15. You can as well go to h over 4, h over 4, and then h over 8 will give you 0.6 divided by 8. So that will give you 0.075. So if you have to use now this one, so you'll have now, this will help you to get you, this one will give you I1, this one will give you I2, this one will give you I3, this one will give you I4. So therefore, just now form your table. So remember, I1, I2, I3, I4 are bound by trapezoidal rule. So just write your scheme as I1, I2, I3, and then I4. So then now between I1 and I2, right? So we have labeled 1, 2, 3, 4. So come here and label this one as 5. This gap 6. This gap 7. This gap we call it 8. This gap we call it 9. This other gap we call it 10. And just remember now to define. So this becomes the scheme. So remember then from this scheme to define I5, it is simply given by 1 over 3 into 4. So I5 is between 1 and 2. So you pick the 4 times the lower one, I2, minus I1, which is the upper one. And then I6 will be a third into 4. Lower one is I3, minus upper one is I2. And then I7 will be a third into 4. Lower one is I4, upper one is I3. And then I8 is a third into 4. Lower one is I6, upper one is I5. And then I9 will be given by 1 over 3 into 4 times I7 minus I6. And then lastly, I10 will be given by a third into 4i9 minus i8. And you simply get your values without struggle. Now, I assume now we have this integral. Actually, the scheme, you can write the scheme, make it even larger by varying the values of h. So, assuming we have the integral of from 0 to 2 f of x dx. So we can say, let's pick h to be 1. H over 2 will be given by 1 over 2 h over, so remember it is 2, 1, 2, 4, and then h over 4 will be given by 1 over 4. H over 8 will be given by 1 over 8. H over 16 will be given by 1 over 16. So therefore now, this is how you form your scheme. So this one corresponds to I1, this one I2, this one I3, this one I4, this one I5. And then you come and write your scheme as I1, I2, I3, I4, I5. And then, so you have labeled 1, 2, up to 5. So therefore now, this other spacing now, 1 and 2, because we have reached 5, then you call this one 6, call this one 7, call this one 8, you call this one 9, call this one 10, you call this one 11, call this one 12, call this one 13, you call this one 14, you call this one 15. The way we define now, so this becomes your scheme. Now, these are already given to you. So this obtained by trapezoidal rule. So the thing will be now to define these other meaning, i's. So just remember to define I6, this position, it is usually a third into 4 times lower one is 2 minus upper one is 1. And then I7 will be a third into 4, lower one is 3, upper one is 2. I8 in this scheme will be a third into 4, lower one is 4, upper one is 3. I9 will be a third into 4, lower one is 5, upper one is 4. etc. Up to the last one, I15 will be given by a third into 4, the lower one is 14 minus 13. And then you can always find the values because it's not very hard to apply the trapezoidal rule. So I advise you to do as many examples as possible so that you can be free to apply Romberg's integration. Thank you.